Hi guys, you're welcome to my channel. So we're going to be looking at the second topic as far as the jamb syllabus is concerned. Remember, in the last class we look at measurements and units. If you are here to get the video on measurement and units, you can check the description box below to get the link to the video. And for today, we are going to be looking at vector and scalar in jamb perspective. What I mean by jamb perspective is that what exactly jamb wants to test on this particular topic. If you are interested in knowing the full topic, like you want to watch the complete video of this topic, check the description box below. I will also drop the link to this particular topic where you can learn it in detail. Is that taken now? So, without any further ado, let's commence today's class. When you talk about vector and scalar, automatically you are talking about quantity. In physics, we can talk about quantity in terms of fundamental and derived, which we covered in the last class. But we can also talk about quantity as a scalar or as a vector. When you say a quantity is a vector quantity, that quantity is said to have magnitude and direction. And when you say a quantity is a scalar quantity, that quantity is said to have only magnitude, no direction. Am I making sense? A vector quantity has both magnitude and direction. That is, if you have the magnitude, it's not enough to explain that quantity until you get the direction. But for scalar, only the magnitude is okay. And that is why the resultant of a scalar quantity is quite simple to get. And if I have a scalar quantity, for example, 5 kilogram, and I have another one of 6 kilogram, there's no stress in knowing their resultant. For me to know their resultant, all I just need to do is to what? Find the algebraic sum of the two quantity. Then I'm going to be having 11 kilogram. But absolutely, this is not like that for a vector. The first thing you need to consider for you to know if you are going to add or subtract a vector when you are determining their resultant is to know their direction. And when they are facing the same direction, they tend to be summed together. When they face opposite direction, you take their difference. For example, I didn't bother show the direction of these two quantities. But if they are vector quantity, let's say I have a force of what? 5 Newton acting in this direction. And I have a force of 6 Newton acting in this direction. These two, for me to get their resultant, I need to take what? Their difference, because they are facing opposite direction. So their resultant would now be 6 Newton minus 5 Newton. And I'm going to have just what? 1 Newton. In what direction? Since the 6 Newton is greater than the 5 Newton, therefore, the 1 Newton is said to move in this direction. Do we understand that now? That is that about a vector and a scalar. Now, jamb as exam body now want to ask you, do you actually know some of the examples of quantities that are vector? And do you know examples of quantities that are scalar? And that is why we should start from the examples of a vector quantity and example of a scalar quantity. Now, when you talk about scalar quantity, we have the following to be example of scalar. Mass. At least I'm going to give you 15 examples each for vector and scalar. So pay maximum attention, as this will help you to solve almost all the whole examples that jamb might brought up as far as vector and scalar is concerned. So I have mass, I have length, I have time. These are examples of scalar. Take note of that. Mass, length, time, current, luminous intensity, amount of substance, magnetic, we have density, we have pressure, we have work done, we have energy. Now, before I go on, let you understand something about energy. All forms of energy, either it is chemical energy, either it is electrical energy, either anything called energy, either it is kinetic or potential, so long it has the word energy, it is a scalar. All forms of energy are scalar. So take note of that, because jamb likes to combine kinetic energy, potential energy in an option. So don't think because kinetic energy has to do with motion, then it's going to have a direction. No. By definition, kinetic energy is an example of mechanical energy. The energy that you use to do work in motion is kinetic energy. So it doesn't change from the ability of doing work. Are you getting this now? So it's just a magnitude, no direction. Please take note of that as you are writing your exam. Is that taken now? So let's move on. Mechanical advantage. Velocity ratio. Efficiency. Resistance. Inductance. Impedance. Charge. Let me put it all. Electric charge, electric current, take note. Potential energy, potential difference, electromotive force, electromotive force. All of these are examples of scalar, including temperature. Do we get this now? Power is also a scalar. Stress is a scalar. Do we get this now? Okay, sorry. Strain, I mean. Okay, all of these are some of the examples of a scalar quantity, of which jamb will not go out of all of this. Am I making sense now? So let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. I think I've tried. That's it. So all of these are the examples of a scalar. So now what are the examples of vector quantity as far as jamb is concerned? I'll be giving you those examples that you might not find in your textbooks. You might not find them in your textbook, so please pay maximum attention to them and get to know them at a go. Is that taken? So let's see example for vectors. So for vector quantities, examples for vector quantities, we have 1, acceleration, displacement, velocity, force, momentum, moment, torque. This torque is also known as moment, but moment of a couple. Are you getting it now? So it's also a vector quantity. So the next one, force field. field intensity, stress, either tensile stress or ordinary stress, it is a vector quantity. Then we have a temperature gradient. Then we have a magnetic induction. Magnetic induction is the same thing as a magnetic field intensity. Is that taken off? So please take note of that. Then we have and it can also be called magnetic flux density. Magnetic flux density. So please take note of that. It's also known as magnetic field strength. All field strength or field intensity, they are vector. Being it a gravitational, being it electrostatic, being it magnetic. So you have to note that. Then the next one I have here is a current density. Current density is a vector quantity. So all of these are examples of vector and scalar. I believe we understand this now. So having said that, what is resultant of a vector? That is another area where examiner wants to tell you as far as a vector and scalar is concerned. When you talk about resultant is a single vector that will have the same effect as two or more vectors acting at a point. You take, for instance, you want to buy a radio. You need MP3, you need a torchlight, and you need a Bluetooth. Now, those are three different gadgets that you actually need. Instead of you buying these three, if you buy one that has what? Torchlight, that has MP3, that also have the Bluetooth, that one is a resultant to what? To the other ones, because it can perform the effect of what? The whole of the three gadgets. For example, in your country, Nigeria, for example, all of you cannot go outside country, isn't it? Now, outside country there, your president cannot be there to represent you. Therefore, you have what? An ambassador. That ambassador is a resultant to your country. Do we understand what they call resultants now? In your class captain is a resultant to the class, because whenever they have any information for the class, they call on your class captain instead of the whole of the class, because they know passing the information to the class captain is like passing the information to the whole of the class. Am I making sense? That is what we refer to as a resultant. A single vector that will have the same effect as two or more vectors acting at a point. Now, examiner always want to test, can you actually determine the resultant of vectors? But before we look into that, I would like to explain how to determine the resultant of two vectors that they are not perpendicular, they are not at any angle to each other, but with their direction, you should be able to determine their resultant. Just like the example we gave earlier, that if I have a force of 5 Newton in this direction, and I have a force of 6 Newton in this direction, the resultant, that is the single vector that will equivalent these two vectors, is what? Is going to be R equals 6 Newton minus 5 Newton, and that is just what? 1 Newton in this direction. Am I making sense, guys? Okay, if that should be the case. Now, how can I determine? Because if I give you a vector now, if I say this is vector A, absolutely, if you are not blind, which I know you are not, you can tell me that this vector is facing this direction. If I give you another one, vector B facing this direction, you can easily tell me that vector A and B are facing the same direction. But if I have something like this, and I have something like this, you can tell me easily that they are facing opposite direction, isn't it? It's cool. But jamb will never ask you question so directly like this, because this is quite what? Simple. Are you getting this now? Now, they can all come in different way to ask you this same question. Just for example, you can have a shape like this. And this will be like this, and you have this, and let's say this is like this. So this is also obvious that this vector and this vector, they are not equal. Forget about the property of what's it called? The property of a rectangle. That is, the opposite sides are equal. If this one is 5 Newton, am I making sense? This one cannot be 5 Newton. It's going to be 5 Newton, but it's going to be what? Negative, in order for them to be equal. Why? Because they are not facing the same direction. So if I have what? A force of 5 Newton going in this direction, and I have a force of 5 Newton going in the other direction, for these two to equal to each other, do you know what will happen? It must be 5 Newton of this one equals to negative 5 Newton of this one. Is that taken up? Because of what? Direction. They are equal in magnitude but opposite in what? Direction. This negative is telling you that they are not of the same direction. For them to be of the same direction, this negative will not be there. Are we together? So that should be the case now. This and this are facing opposite direction. This and this are also facing what? Opposite direction. Just always look out for the arrow. Now they cannot make it more complex than what we have here. And how? Let's see. You might be given a diagram like this. Let's consider these 3 points in space, and if I connect them like this, let's say I have this, and I have this, and I have this also. So let's say this one is going here. This vector A and this vector B. Now, if you have vector A and vector B, the third vector is going to be the resultant of these two. Just like this vector and this vector, their resultant is this. This vector and this vector, their resultant is this. Am I making sense? Now, how are you going to get the value of this resultant? Are you going to have these two, or you are going to subtract them? Now, you have to subtract them if they are facing opposite direction, and you have to add them if they are facing the same direction. But how are you going to know if they are facing the same direction or not? Don't let your eye deceive you. In most cases, it's not always what you think. But you always get your answer correct if you can follow this principle. And what is the principle? If I have a vector A like this vector is having 2 reference points. Are you getting me now? Initial points and the terminal point. I see this now. It has initial point and the terminal point. Look at these two. For all vectors, they always have this reference point. If I have another vector, vector B, this vector would also have what? The same property. Initial and the terminal. This terminal point, you can refer it as what? As the final point. Are you getting this now? And this initial, you can refer it as the starting point. Am I making sense? Okay? If that should be the case, then let's look at something. For them to be facing the same direction, for these two to face the same direction, what happens to be the terminal point of this? Must be the initial point of this. Are you getting this now? And what happened to be the initial point of this one must be the terminal point of this. If it is like that, then they are facing the same direction. But if what happened to be the terminal point of this is the same as the terminal point of this, they are facing opposite direction. If what happens to be the initial point of this is the same as the initial point of this, they are facing opposite what? Direction. So let's come back to this diagram. If you look at vector A, the terminal point of A is this place because that's where the arrow is pointing to. And if you look at vector B, the initial point of vector B is here. You can see that what happens to be the terminal point of A is what happens to be the initial point of what? B. Therefore, they are facing the same direction. So if that should be the case, this third part, which we can call what? C, is going to be A plus B. Are you getting this now? So if that should be the case now, let's now consider this side now that we refer to as C. You will see now that for C, the initial point of C is this point here. And the initial point of A is also the same point. That's to tell you that A and C, they are having the same initial point. According to what I've explained earlier, answer yourself now. Are they facing the same direction or opposite direction? Correct. They are facing what? Opposite direction, because they are both sharing the same initial point. Therefore, their what? Their resultant, which is B, is going to become what? Is going to be A minus C. Have you seen this now? It's going to be what? A minus C. Now let us now consider what? C and B. For C and B, if you look at the terminal point of B, it is this point. Terminal point of C is also what? This point. Terminal point of C and terminal point of B, it is the same thing, isn't it? And if terminal point and terminal point are the same thing, are they in the same direction or opposite direction? Correct. They are in what? Opposite direction. Therefore, their resultant that happens to be what? A is going to be what? C minus B. Have you get this right now? So that is how we determine if two vectors are facing the same direction or not, and that is how we can get their resultant. Now let's move forward and see how to find the resultant of two vectors that are perpendicular. If two vectors are perpendicular, how can we determine their resultant? Let's take for instance that I have two vectors A and B that are perpendicular to each other, just as shown in the diagram. A, this is A, and this is what? B. They are perpendicular. When I say two lines are perpendicular, it means they both form angle 90 degrees. How do you determine their resultant? Since this is the point which they what? They both act together. So this is going to be what? Their resultant, which is R. If that should be the case now, we take this down. This is R. This place is also going to be what? A. Whereby here is B. This place will also be what? B. So if you look at this now, if I call this A, O, A, B, and C, I'm having two right angle triangle here. Right angle triangle OCB and right angle triangle OAB. Now, this is the direction of this resultant known as what? Theta. Why is the direction here? You read your angle in respect to what? The North Pole and the South Pole. So if I start reading here, I'm going to stop somewhere here. So if here is theta, here will also be what? Theta. Because alternate angles are equal. Okay, guys? If that should be the case, I can consider any of these two triangles. But I'll be considering what? I'll say consider right angle triangle OAB. So if you consider right angle triangle OAB, I'll be having my theta here, and this will be angle 90, this will be A, and this will be B. And this will be our resultant that we are looking for. For me to get this resultant, I have to use what? Pythagoras theorem. That is R square equal A square plus B square. So R now equals square root of A square plus B square. And this is how to determine the resultant of two vectors that are perpendicular. But is that all? No. Because it is a vector, therefore there must be direction. So the next thing you need to do now is to determine the direction of R. And how do you determine that? You find the value of what? Theta. So tangent of theta is going to be opposite, which is B over adjacent, and that is what? A. Therefore, theta equal arctan of B over A. So whatever you have as the result of theta, that will determine your direction. Class, let's assume that theta is 46 degrees, for instance. It can be any value depending on what the value of B and A will be. So let's say it is 46. How do I get the direction? I'll draw my cardinal points, north, south, east, and west. Then I read from here, and that will be what? 46. So if I take it like this now, this will be 46 degrees. That will be north 46 degree east. Are you getting this now? Or you write it as 46 degree east of north. Do you understand that now? So that is that about what? About the resultant of two vectors that are perpendicular. Now, what if those two vectors are not perpendicular? What if they are at a certain angle? Let's say, for instance, they are inclined at an angle of 60 degrees. How do we determine their resultant? Because now they are not perpendicular. It's simple. Then we are going to look at the parallelogram law of vector that states that given two vectors that are what? That are inclined at a certain angle, theta, and they are both moving simultaneously. I get to this now. They can both be represented with the adjacent sides of the parallelogram, and their resultant can be determined by the diagonal line of the parallelogram drawn from a point. I'll take it again. Parallelogram law of vector states that given two vectors that are moving simultaneously to each other at a certain angle, they can both be represented in magnitude and direction by the adjacent side of the parallelogram, and their resultants can be determined or represented with the diagonal line of the parallelogram drawn from a point. Like I said it at the beginning of the class, check the description box below and watch the full class on vector and scalar. So if that should be the case now, then we can now draw our parallelogram. If I have a parallelogram like this is a parallelogram, okay? This is a vector u and vector v. This is the angle in which they are both inclined. Then, this is the diagonal line of the parallelogram that we use to represent their resultant. If that should be the case now, if I look at this now, I want you to see something right now. This angle here is going to be what? Angle theta. Am I making sense now? Because the angle here right now is going to be what? 180 minus theta. Are you getting this now? So if here is 180 minus theta and here is theta, what else can I do? So what I think I need to do right now is just for me to find the value of r, and I can get that using what? The cosine rule. Get better explanation of what is happening here in the video that I asked you to watch in the description box if you are yet to watch it. Okay, if that should be the case now, r squared will become what? U squared plus v squared minus 2uv cos of 180 minus theta. So r squared equal u squared plus v squared plus 2uv cos of theta. Now, I explained this in that video, but for the sake of those who actually wants to know why this one become plus and why is this one theta now, it's because cos 180 minus theta, if theta is an acute angle are those angles greater than 60 or equal to 60, but less than what? 90 degree. Anything that makes theta to be less than 90 degree, the value of what 180 minus theta will be greater than 90 degree. And if the value of theta is greater than 90 degree and it's not up to 360 degree, then cos is going to be what? It's going to be negative. Therefore, I will have that cos of 180 minus theta is negative cos of theta. Am I making sense? And do you get this right now? So if that should be the case, if you put the negative here, negative times negative will become what? Positive. So that's that. So r now become the square root of u squared plus v squared plus 2uv cos of theta. And that will give you the resultant of the two vectors. And if you are asked to look for the direction of this, because it's a resultant, there's need for direction. Though at times jamb might not ask. But I'm saying this for the sake of those that might be writing ahead, they can also benefit from the class. Nobody says only for jamb only, but the focus is for jamb. But YX students can also benefit from it. So if that should be the case now, how do I get my direction? Let me say my direction is beta. And if I take this one down like this, this place is already what? U. If I break this what? Vector into components, you understand resolution of vector if you watch that video. That is where I'm going to be referring you to cut this video short. If that should be the case, this one will become u sine of theta and this one will become u cos of theta. Therefore, the tangent of beta will be opposite, which is u sine of theta all over adjacent, and that is v plus u cos of theta. So beta equal the arctan of u sine theta all over v plus u cos of theta. So whatever result you have there is the direction of the resultant of the two vectors. That is the second one. The third way of jamb asking you about resultant of vector. What other way can they ask you? Yes, they can ask you, what if those vectors are more than 2? How can you determine their resultant? It's also simple and awesome. What you just need to do is to consider this. Let's say I have 4 vectors, and this is F1, and I have this is F2, and this one is making angle theta 2, angle theta 1, and this is F3 making angle theta 3, this is F4 making angle theta 4. Upward is the y-axis, down here is the x-axis. So whatever value of y that falls upward is going to be positive. Whatever value of y that falls downward is going to be negative. Whatever value of x that falls to the right hand side is going to be positive. And whatever value of x that falls to the left hand side is going to be what? Negative. Am I making sense, guys? Okay, if that should be the case, what you need to do now is to create a table. And I'll tell you, jamb cannot give you a difficult question that will take you much time, like what I want to do now. And I'm going to show you an example of what you should be expecting from jamb. Now watch, this one will be the resolution of the forces on the horizontal axis and the resolution of the forces on the vertical axis. Please do well by watching the class that I dropped for you in the description box. It will allow you to understand more about this topic. Now, this is the resolution of the vertical component. These are of horizontal component rather, and that will just become F1 cos theta 1. This one will become what? F1 sin theta 1, and this one will be F2 cos theta 2, and this one will be F2 sin theta 2. This will be negative because F2 is falling to the negative axis of x. And the next one will be negative F3 cos theta 3, and this one will become negative F3 sin theta 3, and this one will be what? Positive F4 cos theta 4, and this one will also be what? Negative F4 sin theta 4. So what is the next thing that you're supposed to do after what? Resoluting all of this? The next thing you want to do is to add up all these ones. So when you add up all this, it becomes summation of the forces along the horizontal component. And if you add up all this, it becomes summation of the forces along the vertical component. Let's calm down and explain something here, guys. What exactly do you want to get here? Jamb might come and say, find the resultant of the horizontal component. Note, it's not the same thing as finding the resultant of the O vector. They are only asking you for the resultant of the horizontal component. And this is it. Whatever result you have, when you sum up the whole of the horizontal, is the resultant for the horizontal component. And they can also say, find the resultant for the vertical component. You don't need to stress yourself. You are not looking for the resultant of the O vector. You are only looking for what? This one. Are you getting this now? So what if they now say find the resultant of the O forces? All you just need to do is to represent these two with the adjacent sides of a triangle. That is, I'm going to draw a triangle like this, and I will have this to be my horizontal component, and this will be my vertical component. So here will be my what? Resultant. So the resultant will be r squared equals summation of f squared plus the summation of what? F of y squared. Then r will become the square root of summation of f of x squared plus the summation of f of y squared. So whatever results you have here is the resultant for the whole vector. Am I making sense now? Now, what other question will jamb want to ask you based on this? Jamb can give you a question like this. And let me say here is vector A and here is vector B. Then let's say here is vector C. Now, let's call this angle alpha and call this angle beta. Are you seeing it now? You can see that jamb is not coming as direct as this kind of a diagram. You can see where they are bringing their own diagram, but just note, this is a vector that is more than 2. So for you to tackle this particular question, all you just need to do is to pay attention to what it asks you to do. Now, jamb can say, find the resultant of the horizontal component. Are you getting this now? Or what will be the total what? The total force along the horizontal component. Or they can ask you that what is all allowing for resultant? I don't know. But those are the things they want to ask about what? The horizontal only. If they're asking about the horizontal component only, you don't need to stress yourself. Just say summation of f of x. You know, I told you that earlier here, that the summation of f of x is the resultant of the horizontal component. And that will just be what? This force that you are seeing here, it has a 0 angle. It's making angle 0. Therefore, it's going to become what? C cos of 0. C cos of 0. Are you seeing it now? Because it's not making any angle with the horizontal. It's already an horizontal force. So the next one is going to be plus. Why is it going to be plus? Is because the whole of this force is pointing towards this side. So if that now be the case, this one, which is B, is now going to become what? B cos of alpha. Because B is making angle alpha with the horizontal. Then for A is going to be what? Plus A cos of alpha plus beta. Why? Because the angle that A is making with the horizontal is right from here to this place, not from here to this place. So you have to be careful. So whatever result you have when you add all this together is the result for the horizontal component. Am I making sense? So if that should be the case, what did they now say? Find the resultant of the vertical component. It's also simple. It's just going to become what? The summation of f of y. This one is having what? It's having a 0 angle with the horizontal, isn't it? Because it's an horizontal force. So it's going to become what? C sine of 0. Plus, this one will become what? B sine of alpha. Plus A sine of alpha plus beta. They are all positive because they all make the whole of their vertical axis is towards the positive axis of y. Do you understand us now? And if the question now says find the resultant of the what? Of the whole of the forces, you don't need to stress yourself. Just obtain the result for this, obtain the result for this, then you come here and represent it to the adjacent side of the triangle. Then you arrive at your answer. Am I clear now? Okay, if that should be the case, what other question would they ask us still based on this resultant? Is that according to a projectile question, you already know that when they say at what angle will the range of a projectile be maximum? Like by default, everybody knows it's going to be what? 45 degrees, isn't it? The same thing will happen for resultant of the forces. But when you get there, you have to be careful. Now, examiner can ask you, what will be the angle? At what angle will the resultant of what? Of two vectors be maximum? The resultant of two vectors are said to be maximum when the angle between them is 0 degree. When the angle between them is what? 0 degree. Because when you add what? The angle between two vectors to be 0 degree, what it simply means is that those two vectors are parallel to each other. Are you getting this now? And when they are parallel to each other, they are facing the same direction. There might be a contradiction when they say 180 degree, because somebody can tell you that 180 degree is supposed to be the answer, but 180 degree is an angle on a straight line, and the angle on a straight line is pointing towards different direction, because it's just like a number line. If I have an horizontal line like this, are you seeing this now? One is facing here and the other one is facing here. So that's why their angle is what? 180 degrees. Because if I draw a perpendicular line now, I will have 90 here, I will have 90 here, facing different direction. And just imagine that the two vectors are just, let's say 5 Newton and 6 Newton. So if they face opposite direction like this, the result will be 1 Newton. That is if the angle between them is 180 degrees. But if the angle between them is 0, they will be facing the same direction. So you have to what? Add them together to have 11 Newton. This one is very high. Do you understand that now? So I don't want to explore more looking at 45, looking at 90, but just get it that when the angle between them is what? 0 degree, then your result is set to maximum. If you want to see how much I explore on that for 45, 50 and other angle, you can check the video in the description below. Is that taken out? Okay guys, that is all you need to know about resultant. What other thing will they ask you on vector and scalar? And that is equilibrant. What is equilibrant? Equilibrant is a single force that will balance the system of 3 or more forces. A single force that will balance the system of 3 or more forces. Note, I'm not saying 2. I said what? 3. Reason is because 2 vectors cannot make a closed system. That way I'm not having two-sided shape. Are you getting this now? Because it will not make a closed system. Is that taken out? How do we calculate for equilibrant? The same way you calculate for your resultant is the same way you calculate for your equilibrant. The difference is just that equilibrant is equal in magnitude. That is, the magnitude of your equilibrant is the same thing as the magnitude of your resultant, but they are opposite in direction. For example, if your resultant is magnitude 5 Newton and the direction is what? North, your equilibrant will be what? Magnitude 5 Newton, but the direction will be what? South. Am I making sense now? And if your resultant is, let's say, 10 Newton and north 53 degree east, your equilibrant will become what? 10 Newton south 53 degree west. So they are equal in magnitude but what? Opposite in direction. So can we just digest all what we have talked about in this class, and let's take a break, then we'll come back to come and solve the first 10 questions. Then we are going to have the first 10 assessment on this topic also. So let's refresh and come back for that. Okay guys, let's solve the first 10 questions now, and let's see. And this is how I'm going to share the question. We are going to solve 5 calculations, and we are going to solve what? 5 theoretical questions, and we are going to see how we can brush it through. So without any further ado, what is the first question? The first question here states that jamb 1989, jamb 1989 number 1, 1989 number 1. The question tells, which of the following is a set of vectors? Which of the following is a set of vectors? Option A, we have the force, comma, mass, and the moment. Option B, we have the acceleration, comma, velocity, and the moment. Option C, we have mass, comma, weight, and density. Option D, we have mass, volume, and density. Okay guys, the question says which one is a set of what? Vector. When I say set, A set is a collection of well-defined objects. When I say well-defined objects, I say all boys, you won't find girls in their midst. So if they say all vector, there must not be what? Scalar in their midst. Any option that there is scalar in there, you know that it's going to be the wrong option. So let's start from the down part. We have mass, volume, and density. This is a set of what? A set of scalar. Because mass is a scalar, volume is a scalar, density is also what? A scalar. Therefore, it can be our answer. Then the next one is what? Mass, weight, and density. Mass is a scalar, weight is a vector. Weight is a vector because it's the gravitational earth pull on the body. But density is a scalar. So we only have what? One vector there, so it's not correct. Acceleration, velocity, and moment. This will be the right answer because acceleration is a vector, velocity is a vector, moment is also a vector. And that's what we want. So, but for the first one, force is a vector, mass, moment is also what? A vector. So what actually made this option wrong is because of the mass that is part of the option. Is that taken out? So let's go to the second question. The second question is JAMB 1992 number 1. 1992 number 1. Which of the following quantities are scalar? Which of the following quantities are scalar? Roman figure 1, we have electrical potential. Electrical potential. Roman figure 2, we have torque. Roman figure 3, we have momentum. Roman figure 4, we have kinetic energy. Okay, guys, which one is a scalar? That's the question. The question says, which of the following quantities are scalar? So for us to know the one that is scalar here, we need to understand that electrical potential is the same thing as potential energy. So it is a scalar. Torque is the moment of a couple, is a vector. Momentum is a product of mass and velocity. It's a vector, so it's not a scalar. Kinetic energy, we said it, all forms of energy are scalar. So the correct option is going to be what? Roman figure 1 and Roman figure 4. So, and that's option what here? Roman figure 1 and 4, that's option D. That's the correct answer, guys. So we move to the next one, 1983 number 2. 1983 number 2. The question states that which of the following is not a vector quantity? Which of the following is not a vector quantity? A, force. B, altitude. C, weight. D, displacement. E, acceleration. So the correct answer to this, the one that is not a vector quantity is altitude, because altitude is more or less like distance or height or breadth or length. Is that taken out? So it is a scalar quantity there. Okay, I think we've answered our 4 questions now. So let's go to the last one here. Okay, the last one states that, okay, I think, okay, JAMB 2000 number 13, year 2000 number 13, year 2000 number 13. The question says, the resultant of two forces acting on an object, the resultant of two forces acting on an object is maximum when the angle between them is, class, answer that question. I think that's the last thing we say. Yes, it's 0 degree. The correct answer that is what? 0 degree, and it's option D in this place. Is that taken up? So let's move to the what? The next question, that's question number 6. 1995 number 3. 1995 number 3. 1995 number 3. The question says what? We have a diagram there. And here is the diagram. So this is P. This is R. And this is what? This is Q. Are we there? So, what is the question? Can you see the diagram clearly? Yeah. The question states that in the diagram, P, Q, and R are vectors. Which of the following options give the correct relationship between the vectors? Which of the following options give the correct relationship between the vectors? Option A, we have that P equal Q plus R. Option B, we have that P equal Q minus R. Option C, we have that P equal R minus Q. Option D, we have that P plus Q plus R equal 0. Which will be the right answer, guys? Let's what? Start analyzing from the down part. R minus Q, can it be P? Let's check. The initial point of Q is this point, and the terminal point is here. The initial point of R is this point, and the terminal point is here. Abi? So if you look at the initial point of R and terminal point of Q, they are the same point, isn't it? That shows that R and Q, they are facing the same direction. Therefore, P will become what? R plus Q. Or you say it is what? Q plus R is still the same thing. Therefore, the correct answer is going to be what? A. Now let's take for instance that you don't know what to choose. For example, maybe you miss this video or you forget it. What you just need to do is this. Know and understand that these two options, they are the same thing. Are you getting this now? But it can either be what? R minus Q or Q minus R. So these two options are the same thing. So rule them out. And you are left with just what? These two. Understand that when you add up everything together and it results to what? 0. That is when the body is at equilibrium. And they are not telling you that this body is at what? Equilibrium. Therefore, this cannot be what? The correct answer. Then you are left with the correct answer. Is that taken out? So let's go to question number 7. Okay, question number 7 states that, okay, jamb 2011, number 5, paper type C. Okay, so we have this. So we have this diagram there, whereby here is 6.0 Newton, and here is 8.0 Newton. Are we there? Okay, so the question says the diagram above shows two vectors at right angles to each other. The diagram above shows two vectors at right angles to each other. The value of the mark of the resultant, vector is A 12 Newton, B 13 Newton, C 14 Newton, D 10 Newton. So, do I need to stress myself, guys, in solving this? I'll solve it, but I'll tell you the sharp way of getting the answer. Just what? This is 6, this is what? 8, Abi. I know of Pythagoras trick that states that 6, 8, and what? 10. So the correct answer is supposed to be what? 10 Newton. But let's solve and see what the answer will be normal. So I've told you, or we know, that whenever two vectors are perpendicular, for us to get their resultant, we have what? R square equals 6 square plus 8 square. So R square equal 36 plus what? 64. R square equal 100. Abi? So R equals square root of what? 100. And that will give us what? 10 Newton. So the correct answer there is 10 Newton, and that's option D. So we don't need to start determining the direction because the question does not ask for direction. And that's how cool jamb will be, because whatever they don't need, you don't see part of the option, so you don't need to waste your time getting the direction. Is that taken up? So let's move on to 1980. 1980, number 27 or number 3. Is it like you check 27 or number 3? So what was the question? The question says that a tugboat is traveling from Asaba to Onitsha across the river Niger with a resultant velocity of 20 knots. Full stop. If the river flows at 12 knots, the direction of motion of the boat relative to the direction of water flow is dash. I'll take the question again. A tugboat is traveling from Asaba to Onitsha across the river Niger with a resultant velocity of 20 knots. If the river flows at 12 knots, the direction of motion of the boat relative to the direction of water is dash. Sorry, that's what we're looking for now. We're now looking for what? The direction of the resultant. Am I making sense now? We're looking for the direction of the resultant. So now let's see. Okay, we have that the water is flowing in this north direction. Are we together now? And we have the river flowing in this direction of 12 knots. Are you getting this now? And the resultant is what? 20 knots. This is going to be the what? The resultant, which is 20 knots. Are you getting this now? So we are asked to look for what? We are asked to look for the direction of her. So to get the direction, we have what? We have this place to be theta. Remember, you can either read from north to south or you read from south to north. So it means we are reading from here like this. Are you getting this now? So, or you are reading from north directly like this. So, whichever one. So we have this now to be our theta. How do we get the value for theta? We can say our theta is scar adjacent over what? Hypotenuse. This is our hypotenuse because this is what we have here. Are you getting it now? And this place becomes what? Our adjacent. Am I making sense? Because this angle here is alternate to this. So here is opposite. Am I making sense now? So we say cos of theta is 12 over what? 20. So theta equal what? Sorry, what am I doing? 2 here is what? 10. 2 here is what? 6. 2 here is what? 3. 2 here is what? 5. So that's 3 over 5. Abi? So if I have 3 over 5, press your calculator, that will give you 0.6. So cos theta is 0.6. So press your calculator for arc cos of 0.6. So let's check. Arc cos of 0.6 will give us 53.13. 53.13 degree. And if you look at the options, we have option A to be 36.87 degree, option B 53.13 degree, and that will be the correct answer. Okay, so we are on the second to the last question now, and that's 1997 number 6. 1997 number 6. The question says, two forces 3 Newton and 4 Newton act on a body in direction due north and due east respectively. Calculate their equilibrium. Two forces, 3 Newton and 4 Newton, act on a body in the direction due north and due east respectively. Calculate their equilibrium. Okay? So we have two forces, 3 Newton and 4 Newton. They act in the direction due north and due east. So this is the direction of north and this is the direction of what? East. Are you getting this now? So we have the one of 3 Newton to act like this and the one of 4 Newton to act like this. So here is what? The resultant. And here is our theta. Abi? So the resultant, what are we supposed to look for? Calculate for their equilibrium. So whenever we are looking for equilibrium, we calculate as if we are calculating for resultant. So our r square will now become what? 3 square plus 4 square, which is going to become 9 plus 16. So r square equals 25, then r equals square root of 25, and that will be what? 5 Newton. So that's the resultant. Abi? That's the magnitude of the resultant. What's next to calculate? The direction. So for us to get the direction, we have the direction to be tangent of theta, and that will be what? 12. Opposite. This is what? 4 Newton. Opposite over what? Adjacent. That's 4 Newton over 3 Newton. This and this we cancel. Theta will become, tangent of theta is going to be 1.33. So theta is arctan of 1.33, and that will be 53 degrees. So that 53 degree now will be what? North, 53 degree what? East. I say this now. So our result for the resultant is 5 Newton north, 53 degree east. But we said equilibrium is opposite in direction to resultant. Am I right? If yes, then this will become 5 Newton south, 53 degree what? West. And this will be our result. So let's see what the options we have here from jamb. Option A, we have 5 Newton, 53 degree east of north, which is what we calculate first. But that's for resultant. It's not going to be the right answer. Please don't choose that. Option B, 5 Newton 53 degrees west of south, and that's the correct one. That's the correct answer. Remember, I told you south 53 degrees west can also be read as what? 53 degrees west of south. Is that taken out? So we are going to the last question for the day. The last question. Okay? The last question here states that, okay, I think I'm missing this here. Maybe it's 1995 or 1994. You can check that out. I don't really know. Maybe I don't write it correctly. So you can check that out. Okay? But it is number 2 question. So you can check number 2 or number 12. So this is a question here. So I have this to be 30 degrees. And I have this to be 30 degrees. So here is 2 Newton. And here is what? 4 Newton. And the other one is 16 Newton. Are you seeing this now? So the question says, in the diagram, the resultant force along the x-axis is, the resultant force along the x-axis is, it's just like they're asking for the resultant force along the horizontal component. So there's no point. You just say R equal what? 2 cos 0 plus 4 cos what? 30 degrees. Then plus 16 cos 60 degrees. Am I making sense? Cool. So R is just equal to, cos 0 is what? 1. So 2 times 1 is what? 2. Plus cos 30 is 0.866. Abi? Multiply by 4, what do you have? Let me help you to check. You cannot help me to check. Let me help you to check. So that should give us 3.46 plus 16 cos 60. Cos 60 is 0.5. So 16 times 0.5 will give us what? 8. So let's add everything here together. R equal this plus this, that's what? 10 plus this, that's what? 13.46 Newton. And that will be the value for the resultant along the x-axis. Am I clear? Is it clear? You're not clear, you don't know. So let's see the options. Option A, we have 11.46 Newton. Option B, we have 13.46 Newton. Option C, 19.92. Option D, 14.02. So the correct answer is option B. That's 13.46 Newton. At this junction, if you are yet to subscribe to this channel, don't forget to do. Share this video within yourself. And if you are yet to like the video, kindly like. If you have any question you want to ask, you are free to drop it in the comment section. I will definitely respond as soon as possible. Therefore, just expect your exercise in the description box. If you know you did the previous ones, just let me know in the comment section. Have a nice day, guys.